let's talk a little bit about circles. So this says that a circle is the locus of points in a plane that are a fixed distance from a point called the center of a circle. Okay? And so it tries to give you a pretty good definition of a circle there. Basically, there's going to be this point in the middle called the center of the circle. Okay, and the outside of the circle, they're all the same distance from the center of the circle, is what they're saying. Okay, and so it's going to give us some important kind of terminology here, or symbols that help us in our language of geometry. So it says a circle is named by this particular symbol, right? So it's like a dot with a circle around it. Okay, and its center. Okay, so this is circle A in green here. So it says circle A. Again, notice we have this circle right here, and A is the center of the circle. So it says circle A has a radius of R equals AB, okay, and a diameter of D equals CD. Okay, so again, a couple of important things here, I guess, is that the radius equals the distance from center to any point on outside of circle. Okay? And the diameter, okay, is going to be a segment that goes through the center of the circle and let's say touches both ends of the circle, or the opposite ends of the circle, maybe is a better word to say that. Okay, we'll say touches the opposite ends of the circle. Okay, and so let's take a look at, again, I think that's sort of prior knowledge, but you can see from C to D right there on opposite ends, right? It's a straight line, or a line segment that goes through the center of the circle, okay, right here, okay, and it touches the opposite ends, right? And so, again, the radius is going from the center of the circle. It just goes one way to any point on the circle, right? So I could maybe define another radius right here if I wanted to, and call this, E, and this could be, radius AE. Okay. What we must know is that the radius is 1/2 of the diameter. Okay. And again, I think that's mostly skills from pre-algebra that hopefully we sort of remember. Okay. Now it starts to talk about this irrational number pi. Okay, and we've heard this number before, pi. Okay, and it's defined as the ratio of the circumference C to the diameter D, or pi equals the circumference divided by the diameter. Okay, now let's go ahead and just define this word circumference really quick. Okay, so maybe I'll write this in green. Okay, the circumference basically is just the distance around the circle. Okay, so the way that mathematicians actually discovered pi is they had a way to measure the distance around a circle, and then they just started playing around with different circles, and they divided this circumference number by different numbers, and they finally divided it by a diameter, and they found out that they got this irrational number pi. Right? So with any circle, if you measure the circumference or the distance around the circle, and then you divide that number by its diameter, you get pi every single time. Okay? And so it says at the bottom now, when we solve for C, okay, so when we solve for circumference, the formula for circumference, there's two of them. Okay, so here's the first one. We can say that circumference equals pi times diameter. Okay. Also, we know that the diameter is basically 2 times r, right? Okay, and so we could also write this formula as their circumference equals 2 pi r. Okay, so we'll be using both of these formulas, but remember that 2 times the radius is the same thing as the diameter. Okay, so there's 2 formulas that we're actually going to end up using for circumference here. Okay, now I know this is a lot of information, so you may have to watch this video again. Okay, but let's go ahead and just take a quick look at this next page here. Okay, so this next part sort of tells us how we can develop the formula for the area of a circle. Okay, so it says you can use the circumference of a circle to find its area. Divide the circle and arrange the pieces to make a shape that resembles a parallelogram. Okay, so imagine if you have this circle, okay, and you're gonna basically like cut the diameter first, right? So you're gonna cut it right through its diameter, and you're gonna cut it like basically like a whole bunch of slices of pizza, and then you're gonna arrange it to look something like this. Okay, you kind of like have like opposite ends, and you sort of like match these lines up, and this is kind of the picture that you'd end up getting. Okay, now it says the base of the parallelogram is about half of the circumference. So when it says the base of the parallelogram is half of the circumference, this is what it's talking about. Okay, instead of 2 pi r, it's just pi r. Okay, and it says the height is really close to the radius r. So the height that they're talking about right here is right here. Okay, so the height of this particular parallelogram is about the radius. Okay, and so if you recall, the area of a parallelogram, remember, okay, the area of a parallelogram from our last section is just base times the height, right? So if we say the area equals pi times r, you get pi r squared. Okay, so that's kind of how we can develop the formula for the area of a circle. Okay, now what they say on this bottom part is actually the more little pieces that we cut this circle up into and arrange them into a parallelogram, the more accurate our estimate of our area for our circle is going to be. Okay, so this is something that you can actually try if you really want to cut out a circle, and you cut them in half and arrange the pieces. This is something that we can sort of derive. Okay, but we really have to remember these 2 formulas. Okay, so for the circumference and the area of a circle, okay, remember that there are 2 formulas for the circumference of a circle, pi times diameter, or 2 times pi times radius. Okay, and the formula for area of a circle, which we just found, is pi times radius squared. Okay, so this is something that, again, put these in your notes, right? Put a star around these formulas because we will need these formulas, and we will need them either memorized or you'll need to be able to derive them.